Most people are interested in origin stories. We're simply curious as to what was the cause of this thing or that. In some cases, the answer is simple. For instance, my origin is my mom. Pushing back further, you would encounter my grandmother, great-grandmother, and so on. Looking even deeper in time, we could identify the species from which Homo sapiens evolved and continue the chain all the way back to the primordial ooze. We don't understand every detail of that chain, but we do understand the big strokes, and there is no controversy about the general process. However, the biggest origin story of all involves the origin of everything, the very birth of the universe itself. This is another topic about which scientists know a great deal, although, as we will see, not everything. Our universe began about 14 billion years ago in a cataclysmic explosion that we call the Big Bang. People have some misconceptions about exactly what the term the Big Bang really means, so we'll return to that in a moment. The short description is that the Big Bang theory says first that the universe expanded from a hotter, denser form to the cosmos we see today, and the second that the expansion continues today. There are lots of reasons why this theory is now accepted essentially universally among scientists. Let me sketch out just a few. In 1929, Edwin Hubble discovered that distant galaxies are moving away from us, and that the farther away the galaxies are, the faster they are moving. While his studies only involved galaxies about 6 million light years from us, in the intervening century, scientists have peered deeper into space, looking billions of light years away, and everywhere the same story is told. The universe is expanding. A second bit of evidence is the observed ratios of hydrogen and helium we see when we look into space. In 1948, Ralph Alpher, Hans Bethe, and George Gamow published a paper in which they predicted the ratio of the number of hydrogen atoms and the number of helium atoms that would have been produced when the universe was formed. This prediction, which is very straightforward, says that for every 92 hydrogen atoms, there should be 8 helium atoms. All other elements are negligible. When scientists look in the universe, they find that observations confirm this prediction very well. A third bit of evidence was discovered in the 1960s. If the universe was created in a primordial fireball, this fireball had a temperature. As the universe expanded, this temperature fell. In 1964, the temperature of the universe was determined to be 2.7 degrees Kelvin, or 455 degrees Fahrenheit below zero. No matter where you look in the universe, this is the temperature you see. This observation, along with improvements over the last 50 years, has proven to be a goldmine of data from which to understand the early universe. These 3 bits of data strongly support the conjecture that the universe was once smaller and hotter and has been expanding over the last 13.7 billion years. There is much more data than what I've sketched here that adds to the scientific community's confidence in the idea, with one of the more awe-inspiring ones being the realization that collisions in the Large Hadron Collider can generate temperatures not common since the universe was a 1/10 of a trillionth of a second old. In short, all of the data supports the idea of an ancient universe that originated in the blink of an eye. The data is quite compelling, and the scientific community is essentially unanimous in its support of this conclusion. This period of expansion, which does not include the exact instant at which the expansion started, is what scientists mean when they talk about the Big Bang. This is an important point. Precisely what started the expansion is outside the current Big Bang model. So what started the universe in motion? What turned a tiny and compact cosmos into the expanding and glorious mess we see when we turn our eyes to the heavens? The honest answer is simple. We just don't know. So what scientifically credible hypotheses have been advanced as possibilities? Well, perhaps the most common one is that since the universe was much smaller and compact, the laws of quantum mechanics are what reign supreme. Just like the virtual particles we see today, what some scientists call quantum foam, the early universe was filled with evanescent particles. And, just like the quantum mechanics we see today, a rare fluctuation in the quantum foam overcame the binding forces of the small universe and set the expansion into motion. This sounds a bit like waving one's hands, but the phenomena I've mentioned here are things we see today and we understand very well. So the idea isn't so far-fetched. Indeed, it's actually quite reasonable and mainstream. However, this idea isn't the only one put forth by theoretical physicists. One idea is that before our universe began, there were giant multi-dimensional strings, well, membranes really, floating around in some higher dimensional space. Two of them collided, depositing a lot of energy in the process and thereby creating our universe. Another idea invokes loop quantum gravity. In some of these models, the universe has experienced a series of big bounces in which the universe expands, contracts, and begins again. This idea flies in the face of our understanding of the current universe in which the expansion phase seems to be endless. However, maybe some new physics will counteract the observed expansion phase and start a contraction one. A fourth speculative idea uses M-theory, which is an extension of superstring theory, and says that universes have existed for a long time, perhaps forever. These universes bud off earlier universes, one of which is ours, kind of like a blob in a lava lamp. The word we use for this ensemble of many universes is the multiverse. That word can be confusing since the word universe traditionally has meant everything there is. But I suppose the word makes sense if there are several independent universes that don't communicate with one another. The important point when thinking about the beginning of the universe is to separate those things we know from those things about which we can simply speculate. For instance, in the no category, there is no credible scientific dissension over the idea that the universe was once smaller and hotter and has been expanding for about 14 billion years. The situation is a lot murkier when our attention turns to the mechanism that actually began our universe. No honest scientist can tell you that they know the answer to that question. However, just because scientists don't know the final answer doesn't mean that all ideas are possible. Some ideas have been disproven. But for all we know, there is much that we don't. The question of the creation of the universe has tugged at our minds for millennia, and this is no less true for modern man. Scientists continue to think of ways that we can study this question and draw a definitive conclusion, although I am confident that we'll have to wait a long time for the final answer. But you know, the answer will totally be worth the wait.